Okay, hopefully you had success with Charles' law and Boyle's law. And now we're going to try one other example problem. And in this example problem, what's happening is we notice that when we're reading the question, a gas has a pressure of 1.5 atm. Well, we know that we have a pressure here at 20 degrees Celsius. We're giving a temperature. That's looking like Charles to me. And a volume of 3.0 liters. Oh my goodness. So now we have three variables and not just the two that we've been working with. Okay. What would be its volume? So we're going to be looking for a volume for 2 if the pressure is increased to 2.5 atm and the temperature is increased to 30 degrees Celsius. So now instead of 2 variables, we're looking at 3 variables. And what that means is that we are going to be combining Charles' law and Boyle's law together. And we are going to call that the combined gas law because we're combining them together. How creative and interesting is that? So just like before, we know that volume in Boyle's law, volume and temperature are inverses. That looks like Boyle's, but we have to include pressure. We know that pressure and volume are direct, okay? And notice here, if we were to just look at this, that is the same as Boyle's. And if we were to just look at this, that's the same relationship as Charles, and now we're combining them together. So equals P2 V2 over T2. So now simple plug and chug. I might erase on this one to give us a little bit more room, but pressure of 1 is 1.5 atm. Okay. V1 is going to be 3.0 liters. And then we divide it by our T1. Now, I hope you realize that's in Celsius. And as you remember from before, whenever we are dealing with gas laws, we need to make sure that we do convert that temperature into Kelvin. So if we take 273 plus 20 degrees Celsius, we're at 293 Kelvin. And that is going to equal P2, which we're told is 2.5 atm, times our volume, which we have no clue, over our temperature. And this temperature was given to us as 30 degrees Celsius. So we have to add 30 to 273, and we are given 303 Kelvin. Okay. So hopefully this makes sense to you, okay? If we take this formula and plug it in, we come up with what is over here on the right, from here to here. Okay, what I'm going to do is I'm going to go ahead and erase this first part, okay, since we've got our numbers plugged into the formula, just so I can give myself a little bit more room. And normally what I would do is I would probably get a separate sheet of paper and staple it on, but since I'm annotating, I want to stay on the same screen. Okay, and maybe what I'll do to make it a little bit easier to see is I'm going to start writing, as I work through this problem now, I'm going to start writing it in blue, okay? So if I take 1.5 atm, okay, so there's a couple of different ways to solve this algebraically. One of the ways that you can do this is taking and just to get V2 by itself, you're going to flip this part, which means that you're going to keep the left side the same, 1.5 atm over 293 K times 3.0 liters. Oops, this is getting kind of messy. 3.0 liters. That's an L, believe it or not. Okay, this is the first part again. Now, to get rid of this and leave V2 by its side, we multiply each side by the opposite. So it's 303K, so those will cancel out, over 2.5 ATM, which means we're going to have to multiply that on this side as well. Okay, I hope this is not going to totally throw you, but I am going to erase this part right here because I'm running out of room. Okay, so I'm going to multiply by 303K because that's what I multiplied the right side by, over 2.5 ATM equals V2. Okay, so this is what I'm looking at so far. This is from the first side, and this is when I multiplied, when I flipped over the inverse to get rid of it on the right side. So V2 would be by itself. I had to do that to the left side as well, and that's where that came from. So now what I'm going to do is I realize, let's cross off our units. Oh, ATMs, top, bottom, I can do that. Okay, top, bottom, I can do that. That means my answer is going to end up being in liters. Let me use a different color too. Let's go with this color. Okay. And if I take 1.5 times 3.0 times 303, I should come up with 1363.5 liters on the top, divided by 298 or 290. Oops, I think that was supposed to be a 290. No, it's 293 times 2.5. And you know what? I'm wanting to say that I might have done the math wrong on this one. So you're going to see me open this up and just double check my math because I wrote 298 down for some reason. Times 2.5. I did 732.5 divided by 732.5 equals V2. That means if I take 1363.5 and divide it by 732.5, I should come up with 0.5 divided by 732.5 equals 1.86 liters. Gives us a final answer of 1.86 liters for our volume 2. And that is our final answer. And so that's what happens when we combine both Boyle's and Charles' law into one problem and use the combined gas laws. Now for the rest of these problems, you will see that it will give you a hint. It will tell you which law that you will be using. The main thing that I will tell you is that you want to make sure that you are making sure that your units are the same. Okay, so if you're talking about ATM and questions also asking you in TOR, make sure that you convert one to the other if that's needed, okay? If you still are having trouble, let me know. I can point you to some more tutorials or I can come in and work some problems with you, okay? Take care.